There's sort of three kinds of conversation that I think are going on in the tech industry at the moment. If we'd been thinking about the future in sort of 5 years ago, the whole conversation would have been about mobile. And now mobile's happened. Everyone has a smartphone. Mobile is boring. 5 billion people have a smartphone. So what do we do next? And there's sort of three kinds of conversation that come up in technology and around technology. The first of them is ideas for what might happen in the future, what will happen in 2030. So ideas around sort of crypto and Web3 and metaverse and so on. Meanwhile, most of the actual technology industry is deploying ideas from sort of 2005 and 2010, ideas like kind of SaaS and cloud and machine learning. And then the rest of the economy is being overturned by kind of wild, crazy ideas from 2000 or 1995. Ideas like maybe people will buy stuff on the internet. But it kind of took a while for those ideas actually to happen. And so I'll talk about each of those in turn. First of all, thinking about ideas for the future. The tech industry does tend to suffer from a sort of Tourette syndrome, and instead of shouting fuck at kind of random intervals, people shout kind of bots or AI or crypto. And now we are certainly shouting both Web3 and metaverse. And those are both sort of ideas for universal platforms that you might use to kind of remake how consumer internet works, how consumer internet services get built. Meanwhile, we have a whole bunch of sort of deeper, narrower technologies, ideas like kind of quantum or 3D printing or ASICs and so on, that are also kind of important and interesting, but aren't kind of universal platforms to remake all of technology. And so talking about each of those two kind of generalized platforms in turn, first of all, Web3. As I talk about this, I kind of like this quote from Voltaire, who said that the Holy Roman Empire, whose, of course, capital was here, the Holy Roman Empire is neither holy nor Roman nor an empire, which was, of course, true. And the reason I mention this is that cryptocurrency isn't really cryptography, isn't really about currency, or certainly not only about currency. If you call it Bitcoin, then you ignore all the other stuff. If you talk about blockchain, or even worse, distributed ledger, then you're implying that this is just kind of a database, which also isn't true. And so there's kind of a problem just in thinking, well, what is it that we call this stuff? And how is it that the way we think about it shape what it is that we might be building? Now, so I think kind of a useful framing is to think that we've sort of had three waves of crypto, for want of a better term. And the first wave was that this is digital money, digital gold. It's a bearer currency, a store of value, a store of wealth. You can put your money on a USB stick instead of putting it in a bank, which makes absolutely no sense in Austria in 2022, but might have made quite a lot of sense in Austria in 1922, or indeed if you live in kind of Argentina or Lebanon or places like that, that kind of makes sense. And so that was kind of interesting, but not actually a very big thing. Then the second wave is people say, well, you could put a little bit of scripting on this. And so then you might be able to build some sort of deterministic financial product. So you could build a simple lending product, or you could build a simple escrow system, put money into account X, then automatically move it into account Y. And this got you what we call DeFi, or distributed finance, which is essentially what blew up in the last 6 months. And what really has kind of happened there is that a bunch of people reinvented all the stuff that had been done in banking in the last 100 years, which also, of course, meant that they reinvented what happened in 1929 and what happened in 2008 and what LTCM did, and they reinvented CDO squares, and then they discovered why we have a Fed, and the whole thing has sort of imploded. Out of the wreckage of that, however, there was still a bunch of interesting technology and a bunch of interesting ideas, and we'll probably get some kind of interesting products that come out of this. Then the third wave of crypto, which I think is much more interesting to the kind of the generalized technology industry, is to say, well, if you can put some code on a blockchain, then you wouldn't just build money software, you could actually build real software. You could build actual consumer scale, billionaire scale enterprise applications or consumer software on a blockchain. And so that gets you this phrase Web3. This is sort of the next generation of the web. And so an attempt at a way of describing how one could think of a blockchain is that this is a distributed computing system. The blockchain is a distributed virtual machine. And it has a whole bunch of characteristics. It has rules and records, and it has governance and incentives and game theory built into them. And those are all in the code as it runs. And so with open source, you can download the code, but you can't actually see what Google and Facebook are doing with it as it's running. With a blockchain computer, the code is open as it's running, so you can go and see what's happening. You can go and see all the rules and the records and the transactions and the logic as it functions. So this gets you this phrase Web 3, that it's sort of the third wave of the web, where it will all be public and open and transparent, and the users will all have votes. So all the content is created by the users, but with Web 2, the content is then controlled by networks. It's controlled by Google or Facebook or Yelp or TripAdvisor or Zillow or whoever it is. But if you were to build that on a blockchain, then the users would be able to see what was happening, and you'd have control. This is a very sort of religious vision for technology, and technology does tend to have waves of religion. The early internet was very religious, early open source was very religious, and there's an awful lot of religion around crypto. The reality is, of course, that you'll probably recreate all of the old problems in exciting new ways. And so that's kind of a lot of the interesting questions around what happens when that religion meets reality. But another kind of interesting and important aspect of this is speculation. The original Bitcoin paper explicitly designed in speculation as a way of jump-starting a social network effect. So how do you get people to use a network when nobody's using it? Why would you use it if nobody else is there? Well, you give people a financial incentive. And so this is very successful in getting lots of people to buy Ethereum and to buy Bitcoin. The challenge is that now, if you're building a product and you've incentivized your early users by giving them a financial stake in the future of the product, you now no longer know whether your users are actually users or whether they're hedge funds. You don't actually know whether your users like the product or not, or whether they're just using it because they hope somebody else will like it. And that prompts an awful lot of this sort of volatility that we see in Bitcoin and Ethereum as people bid the prices up and down. You see that in kind of microcosm in something like NFTs. I took this screenshot last year, I think, and haven't bothered to update it because the prices swing around so much. And NFTs sort of capture all of the kind of polarizing bullshit that there is around crypto on both sides. And I think the sort of entertaining thing about NFTs is that the technology people think that the tech is bullshit, and the art people think that the art is bullshit, but the art people think that the technology is useful. And that's actually probably the more interesting part of it. The challenge, of course, I think with NFTs, as with a lot of these things, is how early it is and how few people are doing it. If you kind of dig into some of the numbers, yes, there's billions and trillions of market cap, but the number of people actually doing something is something in the low millions, maybe less. You know, NFTs were a huge deal, but there were only 3 or 4, maybe 500,000 actual trading accounts on OpenSea. MetaMask, which is kind of the closest thing we might have to something that might become something like a web browser, some sort of general layer of abstraction, says it's got 30 million monthly active users. How many of those are active? How many of them are actually doing anything? I think the kind of interesting way of looking at this space in general is to go back and compare it to the early internet. And that's not to say necessarily that because the internet became big, this will become big. It's just to kind of think about what it is that we're seeing. And so if you wanted to use the internet in the early 1990s, the first thing you'd need to do is buy a modem, and that would cost several $100s. And then you'd need to go and get a copy of TCP/IP and work out how to install it onto your Windows 3.1 computer, because Windows didn't have IP. Web browsers didn't exist. And then when you'd done all of this, maybe you'd worked out how to use Telnet, you'd got a shell account on a remote Unix computer, you logged into it, you used a program called Pine that let you read email. And then you'd think, okay, I'm going to send an email to the one person on Earth I know that has an email address. And then you'd send them the email, and then you'd phone them up and say, hey, did you get my email? And they would say, hang on, and they'd hang up. And an hour later, they'd phone you back and say, yes, I got your email. Isn't this fucking cool? And this is kind of like what it's like using crypto at the moment. All you can actually do is tell people, I'm using the internet. And all you can actually do with crypto at the moment is tell people you're using crypto. And there's a huge amount of kind of technical complexity and engineering and sort of sophisticated and sort of complexity that has to get solved. But you have a huge amount of kind of interesting possibility and a huge amount of creative energy going into solving those kinds of problems. None of that is to say these will get solved, but the more interesting questions are, well, if and when they do get solved, what will that look like? And I think it's actually very interesting to look at go back to think about open source and look at the iPhone today. Because open source people thought that this would replace the entire software industry and no one would ever buy software and they would destroy Microsoft. And here we are 25 years later, the iPhone is full of open source. And yet it's not open, and yet it has millions of apps and billions of downloads. So what does it mean to say that it's not open? And I think those kinds of questions of complexity and nuance. What does open mean exactly? Where is open useful? Kind of interesting to apply as we look at words like decentralized. Well, decentralized how and where and at what layers in the stack does the user need to know? What kinds of capabilities would be enabled by that? We'll sort of find out, come back in 10 years' time, and we'll see what happens. The kind of similar questions, I think, apply to this phrase metaverse. And metaverse on one level is a much simpler and easier thing to explain than Web3. It's the idea that everybody has VR and AR, that VR and AR become kind of viable mass market consumer devices. This becomes the next universal device after the smartphone. And so I have a pair, everyone has something that looks like my glasses. I can look around the room and see your LinkedIn profile or your Tinder profile or your Grindr profile, depending on where we are and on the time of day and the privacy settings. And it feels like that would be kind of prompt a whole bunch of interesting new experiences. There is a slight problem, though, in that the word metaverse has now just kind of become like a phrase that means absolutely anything cool that might happen in 10 years' time. And so it's become so vague that I almost feel like it's not even possible to say, well, what is the metaverse or what would that look like? Because almost anybody seems to have their own definition, and almost anything seems to be included in metaverse in some way. It could mean anything. So it's kind of useful just to kind of set that term aside and think about, well, what's happening with VR and AR? And the answer there is, well, it's going up. Facebook sells more every Christmas. Is selling a lot at Christmas a good thing? It means people like it, but it also means it's only a Christmas present and not something that you buy at any other time. And it's also much smaller still than something like Roblox. And Facebook has probably sold 10 to 15 million of the Oculus Quest 2, so there's maybe 5 million people actually using them, which is not nothing, but it's still very early. But I think the longer-term question as one looks at this stuff, as one looks at those sort of tangible devices, is that the engineering will get better, the technology will get better, but when it does, what will that mean? And so if we think about kind of contrast what happened with smartphones and what happened with games consoles. With smartphones, we applied 10 years of Moore's Law to a black and white Nokia, and we got the iPhone, and we got this universal computing device. On the other hand, we also applied 20 or 30 years of Moore's Law to games consoles, and most people don't care. The global install base of games consoles is about 150, 175 million units. So it's a big thing, but it's not a universal device, and most people look at a games console and say, that's very pretty, and then leave. Most people aren't interested in that experience. And so this is kind of the question for VR and AR. When the devices get better, how many people will care? How universal will that become? And I think if one kind of pulls those two threads together and thinks about where we might be with both of these in 2030, there's this very sort of deterministic phrase, this is amazing, it must be part of the future. And that was true of the internet and smartphones and open source, but it was also true of things that are amazing but aren't a very big part of the future. I mentioned games consoles. I think drones are another great example here. A couple of years ago, most people in this room probably bought a drone for Christmas. And then 3 days later, you say, okay, I've seen the roof of my house now. You bought a 3D printer and you said, okay, I've made a little Eiffel Tower now. Now what do I do with this? And it turned out that there really isn't much of a consumer use case for drones. There isn't much of a consumer use case for 3D printing. Games consoles obviously are a consumer product, but most consumers don't care. And so this is sort of a question for VR and AR and for Web3 is, yes, this is probably part of the future, but what kind? It's worth remembering that can take a very long time. This is unit sales of smartphones. It took kind of 15 years, at least 10 years, arguably 15 years, before mobile internet devices actually started selling in significant volumes. And it can also be extremely unclear what this will look like at the beginning. So this is a diagram of the internet from 1995, except that it's not just the internet because there were all these other things. So you had all these commercial networks, and you had Minitel and FidoNet and BitNet and all sorts of other shit, and it wasn't clear that the internet would be the only network. It also wasn't clear that the web would be the only internet application and that things like FTP would kind of fade away. And then it wasn't clear how the internet was going to work, how the web was going to work. Tim Berners-Lee's original web browser had an editor built in because he thought this was kind of like a network drive, that it was a document sharing system and that you would browse to a document and then edit it, and didn't really realize it would become a publishing system. And I think that same sort of questions apply as one looks at something like Web3 or VR or AR. You can believe that this is the future and not realize that it won't be Nokia and Microsoft, and not realize that it won't be a document sharing system, and not realize how it will actually work. So there are sort of a bunch of sort of floating questions for what might happen in 5 or 10 years' time, and we can come back and find out and see what happened. And 10 years' time, we'll sort of see what that looked like. Meanwhile, most of the rest of the tech industry is busy deploying ideas from sort of 2005 and 2010, ideas like kind of SaaS and cloud and machine learning. And I think the best way to express that is this wonderful phrase, digital transformation, which I always think sounds like a parody of marketing bullshit. And if you say digital transformation 3 times, then a partner from Accenture will appear in a puff of smoke in the corner of the room and offer your contract. We can test it later. But what this actually means is that, in the 1970s, every big company got a mainframe, and in the 90s, they moved from mainframes to PCs, and now they move to cloud. And that's a kind of a once every 20-year generational change in how computing works. That's still actually very early, only sort of 10 to 15% of enterprise IT spending, only sort of 25% of enterprise workflows have actually moved to the cloud. And the old stuff can hang around for a very long time. So IBM's mainframe install base is still growing. Most people in this room were not born the last time anyone actually thought about mainframes, but the mainframe business is actually still growing. IBM shipped record mainframe capacity in 2020, as measured in compute capacity, or MIPS, which I looked up MIPS, and apparently the best definition of MIPS is meaningless indication of processor speed. But so they all think can hang around for a long time. But when you move to these new models, you don't just change who you buy your boxes from, you change how much software you have. So when you go from a mainframe to client server, you have an order of magnitude more software. When you go to cloud, again, you have an order of magnitude more software because it's so much easier to deploy software. And so this is an illustration of that from Okta, of just how much software there is inside their client base now. And this is an understatement because this is only what they can see. There's also the marketing department has 3 different MailChimp accounts on the corporate Amex cards. And so typically only about half of the IT being used in a big company is actually part of the IT org. The other half is somewhere else. This is from data from Productive, which is kind of capturing that even individual teams within big companies have 50, 75, 100 different applications. And so what is it that happens when you change that software? Well, one part of it is you go through your company and look for things that you can automate. So this is a slide from Vodafone from a couple of years ago. They have about 2.5 million invoices a year, and that's 1,000 people or 2,000 people sitting in buildings all around the world trying to manage that. What would you do with that with machine learning and cloud and workflow and modern software? How would you automate that? There's also kind of a layer to this of how do you just improve terrible old software. This is a wonderful story from a couple of years ago that Citigroup was paying an interest coupon on a Revlon bond, and they thought they were paying $7.8 million, but they actually weren't. They were paying $900 million. And we kind of look at this user interface and you think, okay, I can kind of understand how you might accidentally pay $900 million instead of $8 million, presuming you had it. The fun part is that because Revlon was in dispute with its bondholders, when Citibank accidentally repaid the whole bond, some of the bondholders just kept it and didn't give it back. So there's a big court case, which is why this graphic got released. And so there's a sort of a general incentive as you go through this generational change to do stuff that you couldn't do before. So there's a lot of people that, particularly as we've gone through the pandemic, want to do direct-to-consumer sales for the first time and discover that their system actually just can't do that. And so they need to upgrade, they need to move to modern systems. But a kind of a bigger and I think more generalized, more interesting kind of story is that what a lot of this software is doing, what most new software is doing, is in some way sort of unbundling old software and creating a new bundle, and creating a bundle around kind of workflow and machine learning and communication and collaboration. And so the example I'm using here, this is a company called Frame.io. I could probably now swap this out with an image of Figma, which was a sort of Frame.io was $1 billion exit. Figma obviously was a $20 billion exit. What they were both doing is kind of the same thing, which is that you have a bunch of people who need to see and touch some piece of work. And how do you manage that? Well, it's an email thread, it's a file share, it's a spreadsheet with a list of versions and a list of timecodes and a list of comments. Maybe it's a private Vimeo link, maybe it's a USB hard disk being FedExed around. And what Frame.io does, and then of course what Figma does, is capture all of that software, unbundle it not just from Photoshop, but unbundle it from network drives and email and spreadsheets and turn it into one unified piece of workflow. And there are thousands of companies now just finding some piece of software, some piece of problem, some workflow, something that's being done on Salesforce or being done in Oracle or being done in email and Excel, and pulling that out into some new workflow, some new network, thousands and thousands of times. Meanwhile, the rest of the economy is being overturned by ideas from sort of 1995 or 2000. And I think the best way to express that is that everything that the internet did to music or newspapers is now happening to everyone else. This is an illustration of what that meant. So this is the decline from peak of newspapers and then bookstores and then pay TV in the USA. And the charts are kind of similar here. The point is the time lag, that it takes a different amount of time or people have to work out a different way of doing it, but the process is kind of similar for all of these industries, and there's a bunch of industries now that don't realize they're about to appear on that chart that will do soon. Now, when you go through that process, there's a sort of fairly obvious set of dynamics that all of the value chains and the gatekeeping that were based on physical assets break apart, and you have kind of new entrants and new models and new gatekeepers. And there's nothing very original about this. You could have said this in 1995. The question is, well, when does it happen and how quickly, and when does it happen to your industry? This is what's been happening to pay TV in the USA, which is now down by a third, maybe even a half from the peak, and probably past Netflix on the way up. And the interesting part about this transition is that as you go through that process, you get these new entrants appearing. But those new entrants, by and large, are part of the existing market structure. So here, this chart is showing you TV production budgets for a bunch of companies, including Netflix and including Amazon. But all the conversations around Netflix now and around Amazon's TV business are all TV industry conversations. All the conversations around Netflix are, well, what shows, how many awards should they try and get, what's the ad model, what's the CPM for the ads, how do the ads get sold, what's the targeting, what are the analytics. They're all TV industry questions. There's no software questions around Netflix. There's no technology questions around Netflix. For Netflix, software is just an entry path. It's a new channel that allows a new company to break into an existing market. But once they're in that market, all of the questions are questions that are native to that industry. Meanwhile, some of you may have noticed over here on the right, the BBC, which I think has the largest content production budget in Europe. The BBC on this scale looks very, very, very small. And this is what that means within the UK market. UK 16 to 34s now watch more subscription video, which means more Netflix and Amazon, and then all content from all UK broadcasters combined. And so what's happened here is that companies that were big fish in a small pond, that were dominating their own local market, are suddenly playing in a global market and suddenly facing very different kinds of competitors. Suddenly their suppliers are becoming their competitors. And so the whole basis of competition and their kind of market definition changes. Now, if I sort of shift gear and look at what's been happening in retail, retail has always been kind of a much slower burn. E-commerce has been a slower burn, sort of 1 percentage point of growth every year. And then, of course, we went into the pandemic and we had this surge of growth. So this shows you the UK and the USA. The UK had a much bigger lockdown than the US, and so a bigger increase in e-commerce penetration. It's kind of important to remember that, the future is here, but it's kind of unevenly distributed. So in the UK, about 85% of people made an online purchase in the last 3 months. In Italy, it was only about 30%. And then you see the kind of the spread of growth across, this is the whole of Europe, so then you see the spread of growth across different European markets. Obviously, everybody is moving in the same direction, although there's some, obviously, that have moved much faster than others in the last couple of years. But I think what's kind of more interesting than that is simply to go back to that UK data and split it up. And what I've done here is that normally when you look at e-commerce penetration, you talk about different categories. So you talk about apparel versus food versus toys or books or hardware or electronics or makeup or something, CPG. What I've done here is I've just said, well, what can come through the mail? And because really the only thing that can't come through the mail is food, and which needs its own supply chain. So I've separated grocery from everything else. And so grocery in the UK, online grocery went from 5% to 10% more or less overnight and has kind of held at that level. But everything else was already at 30% and is now at 40%. So what does it mean if you're building a brand, if you're a retailer, if you're in advertising or marketing, if you're in real estate, when 40% of retail is now online? At that point, talking about e-commerce kind of stops meaning anything. Everything is online. And so that kind of fundamentally changes how people think about building businesses. Meanwhile, of course, when you have new channels like this, you have no new toll booths. So Amazon has been building an advertising business for the last couple of years. Up until the end of last year, there was a line in the back of their accounts called Other Revenue, which they said was predominantly advertising. And then at the end of last year, they had to disclose what it was, and it turned out it was all advertising. And they did about $31 billion in ad revenue last year. $31 billion of advertising means that the Amazon ad business is bigger than the global newspaper industry, bigger than YouTube, roughly the same size as global display. In effect, Amazon is the world's third biggest media owner after Google and Facebook, or Google and Meta, I should now say. And so then we have another example of an unexpected competitor, which is Shopify. Shopify did about $175 billion of GMV last year, up from really nothing 3 or 4 years earlier. And that means that it was about 45% of the size of Amazon Marketplace. And so this is an unconventional competitor, isn't a consumer-facing brand, comes from Canada, which most Americans couldn't find on a map. Most other people couldn't find it on a map either, to be fair. And yet this is one of Amazon's biggest competitive questions. Another example of an unexpected competitor is Apple, which decided to use its control of the dominant smartphone platform in the USA to become a major player, a major power player in the online advertising business, has invented this hilariously self-serving definition of privacy, in which privacy means anything that Apple does and not private means anything that anybody else does. Not quite sure the FTC or competition regulators are going to accept that definition on the medium term. But it allowed Apple to become a major power player in the advertising business, which was, again, quite unexpected. And of course, the thing that drives this is that when you change your channel, you change what people buy. You know, when you go online, you don't buy all the same things, but on the internet, you buy different things. And I think kind of the best illustration of that is one more unexpected competitor, which is a company called Shein. And Shein is a Chinese, for anyone who doesn't have teenage daughters, Shein is a Chinese smartphone-only fast fashion brand. It's overtaken Zara and H&M in Google Trends data. It is also larger than Zara and H&M combined in American fast fashion retail. And so this is a company with no stores, that, again, no one had heard of a couple of years ago, that's now bigger than Zara and H&M combined in the world's biggest apparel market. And so if we kind of zoom out and think about what's happening here, you could say the sort of traditional old bundle of how big brands work was all about scale and leverage and operating efficiency. That you had scale in manufacturing, in retail, in advertising, in selling to the consumer. A couple of years ago, I heard Mark Reed, the CEO of WPP, say that in still about sort of 2005, if you wanted to work out your advertising strategy in the UK, all you really needed to do was go and have lunch with somebody from ITV, which is the biggest commercial TV channel, and then you were done for the year. So you set your ad strategy, you have lunch in January, that's your ad strategy done for the year. And it kind of doesn't work like that anymore, that all of those parts of that big brand model have been broken apart, all of them have been unbundled, all of them change, and each of these pieces of unbundling enables new kinds of entrant, new kinds of business, new channels, new advertising opportunities, new kinds of marketing, new kinds of business. And if one zooms out again, for anybody who's trying to talk to consumers, there's two sort of fundamental questions. There's a logistics question, which is like, how do I get it? And a discovery question, which is, how do I know what I want? And traditionally, big companies had a whole bunch of different brands to do that, so budgets to do that. So you would have advertising and marketing and pricing and shipping and returns and, of course, retail, rent. And those would all be separate things. So nobody would say, should we open stores in that country or just advertise there? Whereas now you absolutely say that. Should we advertise there? Should we have free shipping? Should we put our money into Instagram or into faster shipping or better returns? Those all become one question, hence the joke a couple of years ago, rent is the new CAC. Should we put our money into Instagram ads or open new stores? Or should we do it in put our money, if we open stores, do our returns go down? All of those blur into one, which is why one of the sort of the more interesting stories over the summer was that Unilever no longer has a CMO, because the CMO role is now running both the marketing and advertising budget and running the retailing operation, because Unilever now starts thinking about whether it should be selling to consumers. So if I kind of have some kind of concluding thoughts on this. I was asked to talk a little bit about financial markets. Apparently in about 1920, somebody asked Rockefeller what would happen to Standard Oil share price, and he said it will fluctuate, which is probably what the best way to think about this stuff. And we were talking about Zoom earlier. Serendipitously, I made this chart of the COVID rotation. which turned out to rotate both ways. There was a brief moment in late 2000 when Zoom's market cap was larger than Exxon's market cap, which even at the time didn't look particularly rational. But as we go through that and we return, there was also kind of a comparison here with 2000. Because what happened after the 2000 crash was a whole bunch of people said, oh, that internet thing was all bullshit, it was all nonsense, it was all a scam, we can forget about all of it and we can go back to the way the world was before all these idiots were talking about the internet. And you hear people today saying, well, we're back on the trend line. Yeah, maybe. So this is the reason people say that. So this is US e-commerce as a percentage of retail, excluding things like gasoline sales and restaurants and so on. And so yes, you can kind of look at this and say, well, US e-commerce is back on the trend line. There is a denominator problem here, however, because this is what the actual e-commerce revenue looks like. And so there's a sort of a mix of inflation here and a kind of a short-term surge in physical retail. But what actually happened is that US e-commerce kind of stepped forward 30% and then carried on the trend line that it was on before. It's not really back on the trend line, just as I don't think anybody really believes that people are all going to go back to paying $1 million for a New York City taxi cab medallion, and we're all going to cancel our Amazon accounts and go back to buying everything in physical stores. And so it feels like, we had this moment of acceleration, but it's not like we can just forget about the internet stuff anymore. Meanwhile, there's another kind of interesting trend line, I think, and I've checked this chart several times because it was so sort of entertaining. So this is US venture investing year by year. If you squint, you can see the dot-com bubble in the middle there as that kind of small blip relative to what's been happening in the last year or two. And so we had some fairly overexcited investing in the last couple of years. In particular, a company called Tiger Global did over 400 deals in the last 12 months, which is more than a typical venture fund might do in its entire life. And that doesn't actually even seem to be slowing down. And some of this is about the nature of the market, some of this is about the capital markets and interest rates, some of this will swing back and forth. But there's a sort of an underlying trend line I think that's probably more important, which is to think about how big the internet is. And we kind of forget, perhaps, or kind of struggle to internalize the change in the nature of the size of the internet, and the size of technology. The tech industry used to be really, really small. When Bill Gates was on every magazine cover, Microsoft was not a Fortune 100 company, and it sold accounting tools to big companies. It was not actually a very big company. When Netscape launched in 1994, there were maybe 100 million PCs on the entire planet, and most of them were in big companies. There were maybe 20 or 30 million consumer PCs on the entire planet in 1994. Even when Facebook launched, there were less than 1 billion people online. Today, close to 5 billion people have got a smartphone. And that, I think, is really what drives the shift in valuations and the shift in attitudes towards technology. And so one sort of final observation, you actually saw a different version of this chart earlier. The technology industry goes through these sort of generational changes every sort of 10 to 15 years, mainframes and then PCs and then the web and then smartphones. And so one set of questions are, well, what's the next generational shift after smartphones, which gets you to this conversation around Web3 and VR and AR as the next generational change. But the other is just sort of internalize the fact that this has now become a systemically important part of society. And so I think an interesting way of thinking about that is to compare this with the car industry. That sort of the first 50 years of the car industry was what's a car company, how do cars work, who has a car. The second 50 years was what happens when everybody has a car, which gets you images like this. And the technology industry is in a similar sort of place, I think, in that the last 50 years were what's a computer, who has a computer, why would you have a computer, what is a computer for, why is this useful. The second 50 years is, well, what happens when everybody has a computer. And so you could say that the car industry probably created far more millionaires and billionaires outside the car industry, in retail and real estate and everything else, than inside the actual car industry. And I think there's something similar now around the tech industry. There's far more billion-dollar companies to be created outside of tech because everybody has a computer than will be created inside the tech industry itself. And with that, I will say thank you.